Let's jump into 11.2, areas of circles and sectors. Our objective is I can find areas of circles and sectors. So our essential question is, how can I find the areas of circles? Okay, we're looking at areas of circles, but we're also looking at areas of sectors. What in the world is a sector? Well, just to jump to the punchline, here is your sector. It's a piece of pizza, basically, is your sector. And so we want to find the area of the entire circle, and then also be able to find the area of a sector. And it's the same principle as we did with circumference and arc length. Remember how we had part over whole? So the arc length of the length of an arc over the whole circumference equals the measure of that arc over the whole 360. Same deal here with area of sector. Part over whole, the area of this sector over the area of the entire circle, which is pi r squared. So maybe put an arrow going up there, and that's what should I say, area? Yeah, let's do that. Area of circle. So that's the whole equals, and same thing, the measure of arc AB over 360. So you saw here before, measure of arc AB over 360. Okay, so let's back up a little bit, though. Make sure we got the big picture. There are all the pieces. That is the big picture. Let's put all the pieces together now. So the area of a circle, let's go ahead and put a little symbol of a circle there. Area of a circle equals pi r squared. You'll remember that the circumference of a circle is pi d, or you could say 2 pi r, because the diameter equals 2 times r. The area of a circle is pi r squared. So first of all, whenever you see the length squared, then you know that's going to be area. Or whenever you see two lengths square or multiplied times each other, that's always going to be area. So when you think of area, be looking for either a length squared or a length times a length. And anytime that you see length times length or r squared, know that that is referring to an area. That helps you to distinguish it from circumference, which is just a length times some other constants, a length times some other constants. So a sector is a region bounded by two radii of the circle. So here's one radius, and here's another radius, and so these are two radii, and this region bounded by these two radii, and also their intercepted arc. Here's the intercepted arc. This piece of the pizza is called a sector. So this is sector APB, APB, and I think it's going to be where the three letters designating that sector, the center letter is going to be the center of the circle. I'm pretty sure that's always the case. So like I said, to find the area of this sector, you do part over whole. So the part is the area of the sector over the whole area of the circle equals the part, which is the measure of this arc, over the measure of the entire circle, which is always going to be 360. And then if you wanted to solve this for the area of the sector, then you'd multiply both sides by the denominator here, so both sides by pi r squared. On the left hand side, the pi r squared would cancel out, and on the right hand side you would have what fraction of the circle you want times the whole area of the circle. So this is the fraction. So what fraction of the circle are we talking about here? Times the area of the entire circle. So let's look at the book here, and example number 1. We want to find the area of this dial. They tell us that the radius of the dial from the center out to the circle is 2.5 centimeters. So that's easy. We just plug that into our formula of area equals pi r squared. And so my radius goes in, my 2.5 goes into my radius, and that's a piece of cake. That should be no problem either on your calculator. So pi times, and then 2.5. And you guys remember where the squared button is on your calculator here? So let's go ahead and do that. So remember, whenever you clear your calculator, make sure that you always, let's move this over here, make sure that you always hit the clear button twice whenever you clear it. So what do we want here? Pi, here's our pi, times 2.5, and then hit the square button. And so that automatically gives my square, and then hit equals, and my final answer, total answer, is 19.63, and this is rounded to the nearest 100th. So to the right, that number is less than 5, so therefore we do not add 1 to the hundredths. So 19.63. Next problem here, they give us the the area, and they want us to find the diameter. Well, I do know the equation, area equal the formula, area equals pi r squared. So what I can do is I can back solve this, as it were, not really back solve, but I can plug in what I know and then be able to solve for what I don't know. So I know the area is 113.1, and I don't know what the radius is, but I can solve for the radius by dividing both sides by pi, and then to get rid of the square, remember I take the square root of both sides. So in the square root of r squared, of course, is r, and so if I was to plug this in your calculator, you get r equals approximately 6. I guess they're rounding to the nearest unit there. I'm not sure why they would do that, but that's what they chose to do. And they're the textbook writers, so they're allowed to do what they want to do. All right, next page here. They give us what we'd already talked about, this theorem here. So let's forge on to example number 2. And they're asking us to find these two different areas. We want to find the area inside of these radii and also the area outside of these radii. So the area of the small sector here equals the fraction that we want times the whole area. Remember, this is just taking this proportion and then multiplying both sides by the area. That gives us this. So to find the area of the small sector, this central angle is 70 degrees, so therefore the intercepted arc is also going to be 70 degrees. So 70 over 360 times the area of the entire circle, pi r squared. The radius in this case is 8, so plug in 8 for radius, and if I would plug that in my calculator, I'd get approximately 39.1. Now what I could do is find the area of the entire circle, that's be this right here, pi r squared, and then from that entire circle, area of the entire circle, subtract 39.10. I would make sure that you use the entire number, not just the rounded number, and that would give me the remaining amount, what's left over, the area of this remaining sector. Or what you could do here, and what they did, is they said, okay, what fraction of the entire circle is this blue sector, and that is the measure of this major arc, USV. So how do I figure out what the measure of the major arc is? Well, this minor arc is 70, the entire circle is 360, so 360 minus 70 gives me 290. So the fraction of the circle that I want is 290 degrees out of the entire 360, and then times the area of that circle. In that case, I would get 161.97. And yep, that's just the summary of the answer there. Okay, you are ready. Ready to go. And do number one. Here what I've done is taken these guided practice and put those into your notes. I did, though, kind of add the description of left, because this left side is the red and the right side is the blue, just to make it clear since you have a black and white copy here. So the area of the red, this would be the left, so you'd say the area equals what fraction would be 120 over 360 times the area of the whole, and so that'd be pi r squared, and your radius here is 14. The blue sector, you know how to do that, so you're okay with that. Oh, and also, so if you wanted to find the blue sector, you could subtract the area of the red from the area of the entire circle. That's one option, or you could do it by multiplying the area of the circle times what was it? This is 360 all the way around. So 360 minus 120 would give you 240. So this over here is 240. So 240 over 360 is the fraction of the entire circle that you want, that this sector represents. Okay, so go ahead and pause the video and do those three. And now we're ready for example 3 in the book. And in this case, same concept that we've been working with, except here they give you the area of the sector and also the measure of the central angle, and they want you to find the area of the entire circle. So let's go back to our proportion. Is that what they did here? No, they didn't. They kind of they still started with this other formula here to the right. What I would do is just go back to the proportion and say that the area of the sector, 35, over the measure of the, no, I would say the area of the whole, right? Part over whole equals the measure of the sector over the measure of the whole. That's one way to do it. I think that'd be simpler, and then cross multiply. Or you could start with the formula they have here, area of the sector, so we know that's 35, times the fraction of the whole that you want. So the fraction is 40 out of 360, or 40 of 360, times the area of the entire circle. We don't know what the area of the entire circle is, so in order to solve this equation for the area of the circle, what you would do is multiply by the reciprocal. In order to get rid of this, you'd multiply by both sides by 360 over 40. So 360 over 40 would give you, so these 360s would cancel out, the 40s would cancel out, and you'd be left with the area of the circle. And so if you multiply this is 360. No, is that 360? Yeah, it is 360. So if you multiplied on the left hand side, you get 315. Now example number 4, let me just explain it to you real quick. What they want us to find is the area of the region that we want to paint on the outside. So the way we do that is we find the area of the entire rectangle, and then we subtract from it the area that's taken out. So let's take out the area of the semicircle, and let's also take out the area of this square. This is 16 here, this other one is 16, so this is a square down here. So the area of the rectangle is 36 times this entire length here, which is 26. So that's the area of the whole amount here. And then let's subtract from that the amount that's taken out. And to find the semicircle, you know the diameter here is 16, so the radius is going to be 8. And so here's your area. If it was an entire circle, it would be pi times r squared. Your r is 8 at this point. And here's the fraction of the whole that you want. And you only want half of it because it's a semicircle. Or in this case what they're saying is the measure of this arc is 180 degrees over the measure of the entire circle, which is 360. And of course 180 divided by 360, remember you can cross out the zeros here, so 18 over 36.